In this episode, I'll show you how you can use AWS CloudFormation and AWS Command Line Interface, the CLI, to create an application stack that consists of an EC2 instance that runs the Docker for our application and an RDS instance for the MySQL. And then we will deploy an API application using Docker and Docker Compose. Let's take a look at the steps that we're going to go through in this video. I'm going to start by creating a new key pair on AWS. Basically a pair of public and private keys which will be needed later to SSH onto the EC2 instances that we create. Next, I will generate a new access key ID and a secret, and then configure AWS Command Line Interface using the access key ID and the secret that we generated. Next, we will create a new stack in a YAML file that will contain an EC2 instance to start with, and then test that simple stack. And then update the stack to configure EC2 instance with Docker installed on it to make the EC2 instance as the Docker host. And then again update the stack to add RDS with MySQL engine for our application. And that completes the stack creation. Next, I will create a Docker Compose file to define and configure the application service. And the last step is to deploy and test. So let's get started. I have an account on AWS and I'm logged in. Let's go to the AWS Management Console. First step is to create a new key pair. So to create one on the AWS console under Services, go to EC2. On the EC2 dashboard, locate key pairs under the Networks and Security settings on the left-hand navigation. I don't have any key pairs here, so create one. Give it a name. I will name this key pair as AWS-key1. On submitting, it will create a new key pair and downloads the private key, which goes under the downloads folder on my local. Now we can use the downloaded private key to SSH onto the EC2 instances that use the same key pair. Now let's go to the terminal window and create a new project directory. I will name this directory as deploy AWS and go into the deploy AWS directory. Now copy the downloaded key into this directory. Remember to change the file permission of this private key using chmod command. Set the permission as 400 to the AWS key1.pem file. Now this is to ensure that the private key is not publicly viewable, without which the SSH will not allow or it'll just reject the private key. Next, we will need an access key ID and a secret for the AWS Command Line Interface. In the AWS Management Console under the Services under Security and Identity section, pick IAM. The Identity and Access Management. Go to Users section in here. Here we have one user. We could generate an access ID and secret for this user. Instead, let's create a new user. Give this user a name, grant both access types, programmatic access and the management console access. Submit and go to the next page where I'll need to grant access permissions to this user. Let me just check admin access for this user to make it easier. Review the user and permission and submit. A new user has been created now, and there is a new access key and a secret created for this new user. Now let's go back to the terminal window and configure AWS Command Line Interface. So the command is AWS configure. Give this access profile a name. I will name this as demo. And the first prompt is the access key ID. Now let's copy and paste the access key ID from the AWS console for the user that we created. And also, it'll need the secret key. Let's copy paste that as well. And for the default region, you can pick the one that you use the most. So let's use US West 2, which is the Oregon, as the default region. And ignore the output format for now. Done. AWS CLI, or the Command Line Interface, has been configured with a new profile named as demo. Now going forward, when we need to use AWS CLI to interact with AWS account, we would need to specify the profile name explicitly in the command line. Let's start with creating a new stack. I would like to manage most of the stack creation process using AWS Command Line Interface instead of the AWS Management Console, which is the web UI. But we will use the Management Console to verify the results of the commands that we run on the terminal. Let's go to the CloudFormation page on AWS Management Console. Here we don't have any stack created yet. Let's start by defining a new stack in a YAML file. Go to the code editor. Let's open the project directory deploy AWS, which I created, and it has the AWS key1.pem file, which is the private key that we copied into this directory. Let's create a new YAML file for our application stack definition. I will name this file as stack.yaml, but you can name this whatever you want. This new application stack will consist of an EC2 instance with Docker on it for our application and an RDS instance for the MySQL database. The stack definition starts with the resources, where each resource goes by the logical name and its definition. The first resource in the stack will be the EC2 instance for the application. I'll name this as app node. Type of this resource is AWS EC2 Instance, followed by the properties of the EC2 instance. The instance type. It at a high level is the class or the size of the instance that you need for your application. I will pick the smallest possible one or the cheapest one, which is t2.micro. Next property is image ID, which is the AMI or the Amazon Machine Image ID. This is one of the tricky ones, as the value changes by the region that you deploy the stack in. Let's take a look at that. Go to EC2 dashboard, start the launch instance wizard. Here we have a list of AMIs, and for our stack, we'll be using Ubuntu 16.04, which is this AMI. And here is the AMI ID, the one that ends with DC5. Let me switch the region to a different one, say North Carolina. And now notice the image ID changed for Ubuntu 16.04. The one that we saw for Oregon ends with DC5, and this one is different. So let's copy the image ID for the Oregon, which is US West 2 region, and paste that in for the image ID value here. So let's cancel the launch instance wizard. Back to the stack YAML file. Next property to the EC2 instance is the key name. This is the name of the key pair that we generated, which is AWS Key 1. Now this is the basic definition of the EC2 instance. But once the EC2 instance is created on AWS, for us to be able to SSH onto the EC2 instance, we need to have SSH port accessible on this EC2 instance. Along with that, we also need to be able to access port 80, which is going to be our web applications port on that machine. Now, allowing the inbound ports into these EC2 instance will require us to define another resource, which is going to be the security group. Let's create that. I'll name this resource as app node security group, in short SG. And type is AWS EC2 Security Group. Like with EC2 instance, this will have some properties too. The security group description, which is some text that describes what this security group is all about. Next attribute is security group ingress, which will define an array or a list of ingress or inbound connection properties. First one is the HTTP port, which is port number 80, and it does not map to a different port. So both from and to ports are the same, and we will make it reachable from anywhere with the CIDR IP value or the source as 0000/0. And the second one is for the SSH port, which is 22. Again, both are same, to and from port, and the CIDR IP value is again same as for the HTTP port. Now that we have the security group defined for EC2 that has the ingress ports for 80 and 22, let's assign this security group to the app node resource using the security group's property. Here I use the function ref to reference the security group, which is another resource defined in the same stack. Now we have two resources defined in the stack, one for the EC2 instance, and second one is the security group for that EC2 instance. Let's test this stack before adding more resources to the stack or the stack definition file. Now back to the terminal window, we have the AWS command line interface configured already with the profile name demo. Let's create the stack now. And the command is AWS CloudFormation create stack. Give a name to the stack. I'll name this stack as log stage. Provide stack definition template, which is going to be stack.yaml file, and the profile is demo. Let's also mention the region explicitly, the region where we need the stack be deployed in, which will be US West 2 or Oregon. Now, if I don't mention the region, it would pick what's configured for the demo profile as the default, which is also US West 2. But I'll keep this explicitly mentioned in this command for now, but we can change this in the later commands. So everything is good here except the value of the template body, the stack file path, which it expects to be an absolute path with the file protocol. And that will be file:/present working directory /stack.yaml. Hit enter, and it triggered the new stack creation. Now here we have the stack ID displayed as the output of the command. Let's verify the stack creation on AWS Management Console. Go to the CloudFormations page, refresh the stacks, and we have our blog stack being created here. So we can track all the events, progress, and view resources and more. Here, Resources tab lists the 2 resources that we define in the stack.yaml file, app node and app node security group. Now let's switch back to the terminal window. Now here we can list the stack resources using the command line interface as well. So let's take a look at that. Command is AWS CloudFormation describe stack resources for the blog stage stack using the profile demo. Let's ignore the region from the command because it's going to pick the same one from the profile demo. And that listed both the resources created along with the physical ID, status, timestamp, and other attributes. That kind of gives an idea that you can do pretty much everything using CLI and don't really have to switch back and forth between the CLI and the UI console. Now, when the stack is complete, which is complete here, the physical ID field of the EC2 Instance app node turns as a link to the EC2 Instance detail page. Open that in a new tab. Let's take a quick look at the instance details. Instance type is t2.micro. Here is the public DNS and the IP address for the instance, and the security group app node SG that is associated to the instance. Let's open the security group in another tab. Check the inbound section, which has the configuration that we define in the app node SG ingress configs in our stack.yaml. Basically, it allows TCP connections for SSH and HTTP from any source. Now back to the EC2 instance page. Copy the public DNS. If you prefer the shorter version, you can pick the public IP address as well. Now in the terminal window, let's SSH into the EC2 instance using the private key AWS key1.pem, which is in the current directory. So SSH is successful and I am on the EC2 instance app node. But this is just the Ubuntu OS that we have here and nothing else is installed for our applications to run. We need Docker engine installed on this instance. So let's do that as part of the stack creation process with CloudFormation. Exit out of the app node. Let's delete the stack now so that we can create a new one with the changes to our stack definition in the stack.yaml, which would also include commands to install Docker for our application to run. Now there is also a stack update command that we can use in some cases, but in this episode I'd like to keep the scope to cover just the create and delete stack. Now delete the stack, and the command is AWS CloudFormation delete stack. Name of the stack is blog stage using the profile demo. Now this triggers the stack deletion process. Let's verify on the AWS console. While the stack is being deleted, let's update the stack template to add instructions to install Docker. Add the user data property for the app node EC2 instance. So we need to provide base64 encoded script data to this property, for which we would use base64 function and a pipe, and in the next line we will fill in a multiple line script that would install Docker. To make it quicker, I'll paste in some script here, and the first line says it's a bash script or shell script, and rest of the instructions that install necessary packages, update the package source list for Docker source, and install Docker. I think this is a pretty standard set of commands that you would run on any Ubuntu to install Docker. Now with this updated stack definition, let's create the stack again, and this time the app node will have the Docker installed. Let's verify that the previous one is deleted. Back to the terminal window, let's run the command to create the stack again. And the command is AWS CloudFormation create stack. Stack name is blog stage using the template stack.yaml and with the profile demo. Let's verify this in the AWS console, and the stack is being created. A few minutes fast forward, we have the stack created now. Let's open the app node EC2 instance on a separate page and copy the public IP address once again. Now in the terminal window, let's SSH onto EC2 instance using the public address. Here we are on the EC2 instance which has Ubuntu installed. Let's check the process status and grep for Docker, and we have Docker running as well. App node is now our Docker host. But notice by default Docker listens on a Unix socket, which works for locally dealing with Docker, but we need this listen on a TCP port so that we can connect remotely to manage services or containers on this Docker host. Basically, we will need to alter the docker d command to add another option, -h option, to add a new TCP port to listen on. Now let's exit out and delete the stack again. While the stack is being deleted, let's go and update the user data property of the EC2 instance to add some instructions or commands that would make the Docker engine listen on TCP port 2375. Now here I am on the documentation page of the Docker engine configuration. Scroll down to the Configure Docker section that explains the commands and instructions to follow through. Basically, simple 3 steps process. Create this directory and add a new Docker configuration file, which will include the configuration for the Docker engine startup command. And that will be under the service section of that file. xxstart will have -h tcp://0000:2375. This makes it to listen on port 2375 on the host. Let's switch back to the stack.yaml file in the editor. I'll paste in about 4 lines of code and append that to the user data value, which basically does what we just read in the documentation. Which is create a directory and the service configuration with the updated xxstart command with the new -h option to have it listen on port 2375 in the Docker configuration in that directory, and then reload the daemon and restart Docker service. Now that the app node will have the Docker running and listening at port 2375, let's also update the app node security group and add a new ingress or inbound TCP connection for port number 2375. I'll copy the one for SSH and update the port to 2375. That's about it. Let's switch back to the terminal window and run create stack command again. Now the stack is being created. Fast forward a few minutes and we have the stack created now. Now go to the app node EC2 instance page, copy the IP address. In the terminal window, let's verify that the Docker is listening on port number 2375 on the app node Docker host, and the command is docker -h, the host, tcp:// the IP address of the app node or the EC2 instance : port number 2375 space ps. And that returns an empty list as we don't have any containers running in that Docker host. Now the Docker setup is complete and the connection to Docker host also looks good. Next, we will need to run our application on the Docker host app node. Now, before we run our application on the app node or the Docker host, let's add a database to our stack. We will be using RDS for MySQL. Let's delete the stack for now and switch back to the stack.yaml. A quick recap, we have 2 resources defined in the stack, app node for EC2 Instance and app node Security Group. Let's add 2 more for the RDS. I'm going to paste in the code for that, which has 2 resources, one for the database instance and the other one is for the database security group. Database instance is of type AWS RDS DB instance, and the properties are the database name and the database engine, which is MySQL, master username, password, and the instance class. Now this is similar to the instance type property in the app node EC2 instance. I picked the smallest one again. The value of allocated storage for this database, the minimum one is good. And the last property is the security group of the database, which can take an array of security group names. Ours is a simple security setting and we have just one, which is basically a reference to the resource which is defined below, the database security group. Let's take a look at that. Database security group is of type AWS RDS DB security group, not the same as the EC2 security group. Properties will include a description that serves as a documentation as what this security group is all about, and inbound or ingress settings. Now this can be a list of security group rules, but a simpler version is an IP range with the CIDR IP. Here I have set this to this value, which basically makes the RDS database instance reachable from anywhere. Now that completes the stack definition. We have 4 resources defined in the stack: app node security group, database instance for RDS, and a database security group. Now verify that the previous stack is deleted. Run the create stack command again. Now that we have the RDS to be created as part of the stack creation, it will take about 5 minutes as RDS really takes a bit longer than other resources in the stack. While the stack is being created, let's create a Docker Compose file for our application. I will name this file as app.yaml. Now I need an application to deploy. So I'm going to be using the application that we used in episode 6, which is a Rails API only application that exposes some REST APIs to create, show, edit, update, blog post content. That's a very simple set of APIs. The code for that application is on GitHub. Here it is. I'm going to copy the staging.yaml, paste that in the app.yaml, and this is our compose file. Now let's take a quick look at that. Now it defines one service named as app, and the image is on Docker Hub. And here is the repository that you might want to take a look at. App service maps port 80 to host for the container port 3000 where Rails runs. And it expects the MySQL database configurations be passed in environment variables. Now let's update these database configurations using the one that we configured in the stack.yaml for the RDS instance. DB user is blog user, DB name is blog, Password is password123. Quick compare with the stack.yaml, that's exactly what we have configured for the RDS instance so far. And for the DB host, we need to wait for the stack creation be complete. A few other environment variables this application expects. One is the Rails environment, which we will set to production. Basically, the application runs as prod environment and uses the database configurations provided in the compose file. Another one is Rails log to standard output with some value so that the application logs can be viewed as container logs. And the secret key base, which is something that Rails application expects, I will leave these as is as the value is valid. Back in the browser, let's close the tabs except the AWS console. Reload the stacks and we have the new stack created now. Notice the stack now has 4 resources as defined in the stack.yaml. Let's open up the database instance, the RDS instance in a new tab. This is the DB instance detail view. It has the database configurations here, database name, user, and here is the database endpoint or the host name. Let's copy that. In the Docker Compose file, app.yaml, update the DB host environment variable value with this one or the new endpoint and save the file. Now that completes the definition of the Docker Compose file. Now we have the stack created that has an EC2 instance and a Docker Compose file definition for the application is also ready. Let's go ahead and run the application on EC2 instance. Now I need the IP address of the app node. Let's list the containers on the Docker host one more time. As we did before, the longer syntax is docker with -h host and the TCP IP address 2375 PS. Instead, let me just set the environment variable docker host with the same value as -h option in the above command. With docker host environment variable set, and then the command will be docker ps without the -h option. So that works and there are no containers running. So let's deploy the application. Start with running the database migration so that the database that is created on RDS instance has all the tables necessary for the application. And the command is docker compose using the compose file app.yaml run app with the remove option Rails db migrate. Now this will run Rails application as a container on app node EC2 instance with the database on RDS instance. Rails db migrate is complete and let's run the application now. And the command is docker compose using app.yaml up with -d for detached more. It has started up. Let's verify the containers using docker compose ps. And we have one service or the container running. The API application or Rails API only application is running as container and it is available on port 80 on the host, the app node. Now we should be able to access the API using either the public IP address or the domain name. Let's copy the public DNS or the domain name for the EC2 instance and in the REST client request the API. The request type is GET and the URL is HTTP, the DNS name that we copied, port is 80 which is default, /posts. Now we can use posts.json as well, submit the request or send request. And it responded with 200 OK response code but with an empty response body or an empty list of blog post entries in the response. Let's populate some test data using Rails db seed command and the command is docker compose using app.yaml run Rails db seed. Now this is really for testing and normally you wouldn't do this in production environment. Test data has been populated now. Let's go into the REST client and reload the post API page and it responds with some blog post entries. Now let's also test one of the post detail APIs using the URL from one of the post entries in the response. Send request and it works too. That's it. We just created a simple stack that consisted of EC2 instance and an RDS instance along with necessary security groups using CloudFormation for our API only application. And then we use Docker Compose to define the application and manage and run application services on EC2 instance. Now, before I finish up, I'd like to point out a few things that you can explore more about. The first one is the Docker Compose, which I chose to define and run the application on the stack. Now, Docker Compose is one of the many options you have if your stack is small, but one can manage to do the deployment or auto deployment using CloudFormation itself. So that is something to explore. And the second one is about the user data property. In the stack.yaml, the user data property we used to provide the script for the installation of the stuff that we needed on EC2 instance, such as the Docker or configuration of Docker. That's an easy approach, but there are better options with CloudFormation that you might want to explore. The last but the most important one is the Docker service or the Docker engine that we configured to listen on port 2375. Now, except for testing, this definitely is not a good idea as the Docker host in this case does not require any authentication and the communication is not encrypted. Instead, Docker Engine should be TLS enabled with a SSL certificate. Now that solves both authentication and encryption problem. Now that's pretty much for this episode. Thanks for watching.